Hello again, and welcome to the fifth installment of Life Lessons with Hotard, focusing mainly, of course, on Algebra 2. Today, I'm broadcasting from the trampoline in the backyard of the Hotard residence. We're going to be completing our lesson today on solving exponential equations, the second part of exponential equations using logarithms. So I know you're looking forward to that. We're going to go ahead and get started. Okay, today, like I said, we will continue our lesson on exponential equations. All right, we're going to pick up where we left off yesterday with solving exponential equations using the same base method, but I'm also going to show you another method using logarithms. Just a heads up, you will need your calculator for almost every problem today, so go ahead and get that out if you don't already have it. All right, starting with example 1. All right. Looking at this, 3 to the x equals 27. This one, we could use the method that we talked about yesterday, same base. I can rewrite that 27 as 3 to the what power? 3 to the third. So I can say this is just 3 to the x equals 3 to the third. And so I have the same base, so I can just drop the bases and say x equals 3. And that is my solution, because 3 to the third does give me 27. Now, that method is great, and it works wonderfully for that problem, but it does not work on every problem. I'm going to show you another method that you can use for these problems. So if you look at example 2, this time I have 3 to the x equals 32. I cannot write 32 as 3 to some power. I can use that same base method to estimate what the answer is. I know from the last problem that 3 to the third gave me 27. That's too small. And then I also know 3 to the fourth. Do you know what 3 to the fourth is? It's 81. So I know 3 to the third is 27. That's too small. I know 3 to the fourth is 81. That's too big. So I know whatever the answer is, it's going to be a decimal somewhere in between 3 and 4. Now, do you think the answer is going to be closer to 3 or closer to 4? It's going to be closer to 3, because 27 is a lot closer to 32 than 81 is. So it's going to be 3 point something, smaller than 3.5. Now, to find the exact answer, I can use logarithms. So let me just rewrite this problem right here. 3 to the x equals 32. Now, I could use the logarithm method. Basically, what I need to do, whatever the base is base 3 this time. So I'm going to take log base 3 of this. Now, nice thing about algebra, I can do whatever I want to this side of the equal sign as long as I do it to this side of the equal sign. So I need to take log base 3 of 32. Now, if you recall from last week when we were first learning about logs and exponential functions, they're inverses of each other. They undo each other. The whole reason we do this is the log base 3 and the 3 cancel out. What's left on this side of the equal sign? Just an x equals, now that's just log base 3 of 32. That's going to be a decimal number. I need to type that in my calculator. Now remember, if you have a newer calculator, to type log base 3 of 32, you could just hit the math button and then scroll down to where it says log base. You can type it in just like that. If you have an older calculator, you would have to use that change of base formula we talked about last week. You would have to type log of 32, close the parentheses, divide by log of 3. Log of 32, close the parentheses, divided by log of 3 in order to get that exact answer. So it comes out to be about 3.15. So x is approximately 3.15, which makes sense. We said it's between 3 and 4. We said the answer is a lot closer to 3 than 4. So that answer would make sense, about 3.15. Now, before we solve any other problems, you have two methods. You have the same base method, you have the log method. I want to talk about when you should use each type of method. All right, if you look at the problems we had yesterday, when you have basically a variable exponent on both sides of the equal sign, something like this problem or this problem, you want to stick with that same base method. If you only have one variable exponent in the whole problem, like for example, example 2 that we did yesterday, or the problem we just did, a lot of times you could use either method. Like example 1 that we just did, I could have used either method to solve that, but the log method will always work if you only have one variable exponent in the problem. It will always work, even in problems that you could use the same base method. So let's look at these two more examples really quick. If you look at example 3, 4 to the x minus 2 equals 35.6. Again, I cannot use the same base method. I don't know how to write 35.6 as 4 to some power, but I can rewrite it. All right, I've got base of 4, so I'm going to take log base 4 of both sides. All right, so I'm going to have log base 4 of 4 to the x minus 2 equals log base 4 of 35.6. Now, the whole reason I did that is because what does log base 4 and 4 do to each other? They cancel out. That's the whole reason I'm doing that. I'm left with just x minus 2 over here. X minus 2 equals log base 4 of 35.6. And I can type log base 4 of 35.6 in my calculator. 35.6 in my calculator. That's going to give me a decimal answer, but that's not the final answer though, because what do I need to do to get x by itself? I need to add 2. Add 2 to both sides. Now don't add 2 to 35.6. It's not 37.6. Add 2 to what you get when you take the log. All right, so I'm going to, x is going to be equal to approximately, now I'm going to type this in. I'm going to type, let's figure this out. I'm going to type log of 35.6, close that parentheses, divided by log of the base, so log of 4, and then I need to add 2 onto that answer. So my answer is going to be about 4.58. Again, if you have a newer calculator to type log base 4 of 35.6 in, you could just hit the math button, scroll down to where it says log base, and you can type it in just like you'd see it. Just don't forget to add 2 onto that answer. 4.58. All right, one more problem really quick, then y'all are going to try something. Look at example 4. Uh-oh, what's that e? Remember, e is a number. It's just about 2.72. I'm going to treat it just like the others. But before I take log, all right, if you have any extra numbers that don't have the exponents on them, you need to get rid of them. This 10,000, I need to get rid of it before I take any logs. So to get rid of 10,000, it's 10,000 times all this stuff. I'm going to divide both sides by 10,000. Get rid of any extra numbers first. If you have any numbers being multiplied or added or subtracted, get rid of those first before you use the log. So e to the 0.05t equals now 24,000 divided by 10,000. All right, when you're dividing, you remember you could just take the numbers off. If you're not sure, you could always use a calculator. 24,000 divided by 10,000 is, of course, 2.4. You just remove all the zeros. All right, and now I need to get rid of this. So I'm going to take log base e. E is the base this time. Now remember, there's a special name for log base e. It's ln, natural log. So I'm taking ln of both sides. All right, and that's going to cancel out the e. Leaves me with just 0.05t equals natural log ln of 2.4. Now I can just type this straight in my calculator. I don't need to do anything fancy. But what do I need to do to get t by itself? Divide by 0.05. So t is going to equal, I'm going to type that in now, natural log of 2.4, close the parentheses, divided by 0.05. So about 17.51. I should put a little squiggly equal sign because it's not exactly equal to it. I'm approximately equal to that, 17.51. All right, now at this point, I want you to go ahead and pause the video, look at the problems I posted. I have some textbook problems. Try a few of those. All right, make sure you can get those right, check the answer key, and then come back to finish the lesson. Did you do it? Sure you did. All right, now, the last thing we're going to be doing, we're going to be applying this to some real-life applications. We're going to be starting with something you should already know. We did this in the third 9 weeks before y'all left, the compound interest formula. Just a quick review. Remember, A is the final amount. P is the principal, or you could just say initial amount. It's how much you deposit. R, of course, is the rate, or the percent. N, y'all remember what N is? It's number of times per year. Number of times per year. I should say number of times it's compounded per year. Number of times compounded per year. And T, of course, is time. It's years. It's how many years have passed. So this first example, this one is nothing new, all right? We've done this before. Wesley's grandfather gave him a birthday gift of $3,000 to use for college, so there's your initial amount. He deposits the money, the account earns 4% annual interest compounded quarterly. What's that mean? It means n equals 4 times a year. How much money will he have in the account after 3 years? So I'm looking for the final amount, so let's say A equals or Y equals initial amount 3,000 times 1 plus R, remember move that decimal twice, 0.04 over n, we said is 4 because it's quarterly, exponent n times t. So 4 was n times time was 3 years. Just type that in your calculator. I can do this, I promise. 3,000 parentheses 1 plus 0.04 divided by 4. Close the parentheses, exponent 4 times 3, which is just 12. So he's going to have $3,380.48. All right, nothing new there. Now here's where the new stuff comes in. Example 6, how long would it take? So if it's asking how long, it's asking for t, it's asking for time. How long would it take for an investment of $5,000, there's my initial amount, my P, to earn $1,000 in interest if it is invested in a savings account that pays 3.75% annual interest compounded monthly. Now monthly, how many months in a year? 12, so n equals 12. So this time, I know the final amount. If you're putting in $5,000, you're earning $1,000 on top of that. How much do you end up with? $6,000. That's my final amount. 6,000 equals initial amount was 5,000. How much you put in? All right, parentheses, 1 plus the rate. Now 3.75%. Remember, move that decimal twice. So 0.0375 over n. Monthly means n is 12. Exponent n times t. So 12 times, I don't know what t is. I'm looking for t. All right, so a couple things I could do. First of all, I need to get rid of this 5,000. So let's just go ahead and divide that. 6,000 divided by 5,000 is 1.2 equals. Now, I can go ahead and type everything that's in the parentheses in my calculator. 1 plus 0.0375 divided by 12. All right, don't worry about the exponent, but that's what I get, 1.003125. Let's write that. 1.003125 exponent 12t. Now I'm going to solve this using the same method I did on the front. I want to use logarithms. Which number is the base? This big long decimal number. So I need to take log base 1.003125. I need to do that on both sides. Log base 1.003125. Again, the reason I do that, it cancels the log and that exponent cancels. So I'm left with just, over here, log base 1.003125, just be careful when you're typing that in, of 1.2 equals 12t. So I'm going to have to type this big log monster in my calculator, and then once I do that, what do I do with 12t to get t by itself? I divide by 12. All right, so when I do that, I'm going to have log 1.2 divided by log of the base 1.003125, and then divide that answer by 12. There it is, 4.87. It's going to take about 4.87 years. Now, last thing, if it's compounded continuously, that's the formula with E. All right, so I'm going to do the same thing. Investment, $5,000, earning 1,000, so there's my final amount, 6,000. How long will it take? I'm looking for T. 6,000 equals 5,000 E to the R 0.0375. I don't know T. All right, so I'm going to solve it just like the last problem. Get rid of this 5,000 first. Divide that out. just like the last problem, 6,000 divided by 5,000 could be 1.2 equals e to the 0.0375t. Now, I need to get rid of e, so I'm going to take log base e. Remind me again, what's log base e? ln, natural log. So I'm going to take ln, natural log of both sides. That's going to cancel out that e. So I now have natural log 1.2 equals 0.0375t. So I can type this straight in my calculator, but how do I get t by itself? I divide by 0.0375. And type that in. So that's going to give me natural log 1.2 divided by 0.0375. And that will give me about 4.86 years. Okay, so y'all go ahead and try the rest of the problems that I posted. Check your answers. Again, if you have any questions, feel free to email me. I'm checking my email daily between 10 and noon. I can give you a quick response if you email me then. If not, I will get back to you as soon as I can. Y'all be safe. Have a great day. Bye-bye.